Very easy. I don't have the answers. Hold on. Factor theorems. Factor. Ooh, I can't write in that fat stuff like that. That means theorems. HMS. The Munza. The Munza. I am going to introduce you to this by I can't remember if we did this last year or not. And maybe we did it, but we didn't call it this. Yeah. Okay. So let's say we have this polynomial. And I'm definitely going to use one that works. But what do you get if I ask you to first divide Theorems? Is that what you're? Yeah. Theorems. Theorems. Is it OMS? Sure. I always just put THM. It looks kind of funny like that. Y'all are sure? Yeah, you're right. Is it? Yeah. I'm not a speller. Not a speller. Divide this by x plus 4. Just quick, on your own. Mark, set, go. What, all those pencils? Is that better? Oh. Everybody got that? Now do something else for me. Find f of negative 4. Original. You trust me? Okay. I was waiting on somebody to click that to make that connection. Yeah. Look. Y'all been clicking it? Sorry. That's called the remainder theorem. So I take it, did we do it last year or no? No. Okay. Okay. So here's the remainder theorem. I kind of like that yellow color. If you divide x minus some number c, then the remainder will always be f of c. That's what we just did. If you plug in what you divide by, yeah. The opposite sign, right, because it's x minus c here, yes. Does that make sense? So I can use this both ways, right? I can plug in a value to find out if it's a factor to see if I get a zero remainder, or I could say, what would the remainder be if I divided by this? And I can do synthetic division. It's a little bit easier than just plugging in sometimes, right? So let's do a couple examples and then we'll move on. Use the remainder, this is an example. Use the remainder theorem to evaluate, let me write it first. 7x minus 14. Do f of c without actually plugging in. Yeah, and we'll use it to do a lot of other things, but yeah. Just that you can plug in to find a remainder or divide to find the remainder. So you would use -3 in this case, because that is your c. Right. So the directions would literally say use the remainder theorem to find f of -3. And that would mean dividing by. Because the remainder, bless you. Because if I do this, what has that told me at this point? That f of -3 is equal to what? -20. That's all I've done. I think it's pretty cool. Let's do a word problem. The number of tickets sold during the Oakdale High School football season can be modeled by the equation where X is the number of games played. This is number of tickets. Use the remainder theorem to find the number of tickets sold during the 7th game of the season. So I just need f of 7, but because it told me to use the remainder theorem instead of plugging in 7, I'm going to do synthetic division at 7. And there's a reason we're setting up and doing this. Oh, what am I doing? No, don't say that. $229 tickets. Say that again. Well, whenever it's telling you to plug in, so the same number that you plug in here goes in here, but what I really divided by was I divided by x minus 7. All right, factor theorem. I told y'all this was going to be easy. Let me go back. Okay. That was remainder theorem, right? This is factor theorem. This one is the most obvious in my opinion. It makes the most sense. What does it mean to be a factor? Divisible, it goes in with no remainder. So this one kind of goes hand in hand with the remainder theorem. So factor theorem says if a polynomial, and we'll call that polynomial f of x, I'm going to say has a factor of, we'll use the same c, of x minus c, then f of c equals 0. Which essentially we just talked about with the remainder theorem means it doesn't have a remainder, right? It means the remainder. So how am I going to check? I'm going to synthetically divide to see yes or no, is it a factor or not? Well, let's see. Right. So for example, y'all's pencils are just, I'm sorry. Which of those are factors and which are not? Hello.
Like, are y'all getting 518? No, I got that.
That's correct.
Yeah, I got 3,000. Yeah, well, you got 3,000. I got 3,000. No, also, like, I'm saying I got it too.
I got x minus 2 as a factor.
Yeah. Wait, how? Because it's about that.
Where do you see 2 times 8?
Oh, I thought you put 11. Oh. Yeah, guys, I don't know.
When you did 7, negative.
Oh, for 7 I got a remainder of 2,900. Y'all, I haven't got there. We've got 10. Yeah, maybe go ahead. Oh, I'm a liar. I keep forgetting.
I just did it again. $21 carry through 90.
X plus 4. It works perfectly fine. I think X plus 7 is a liability.
I did. I don't trust myself today.
Don't you remember like 9,000 or so? I got 2,900. I got 2,100. Oh, look, they're so cute.
Good icing. It's like buttercream.
Dude, I'm literally gonna like gain weight now. How in the world?
Are you okay? Nope. 7 doesn't work.
Yeah, those are good. Okay, yeah, I went wrong.
How about 4?
Hey, that works. That works for you? Oh, whoa.
Yeah.
Oh, so you're supposed to put a 0 on the end?
Yes. Wait. Oh, 56. I was like, I didn't get 560.
That's what I got.
All right, so yes. Okay, one more thing though.
I'm still on the 4.
Oh. The only thing you're going to do from here is maybe it says find all the zeros given one factor. Okay, so in other words, maybe it looks like this. F of x equals 3x to the 4th plus 5x cubed minus 42x squared plus 40x, and it gives you a factor. X plus 5 is a factor. So, right, so if you're given a factor, if I divide by that factor, think about the way factors work and division works. If I said that 2 is a factor of 6, then 3 is also a factor, and I could rewrite 6 as 2 times whatever I got whenever I divided, which was 2 times 3. I'm going to use that same thought process to say, well, if I divide by x plus 5, 3, 5, negative 42, 40, 0, 4, 3, 2, 1. 3, negative 15, negative 10, 15. I'm running through this kind of quick. I'm sorry. Y'all were like, give me the work, give me the work. Oh, that didn't work.
It's 100.
That doesn't work. No. 3, 5, negative 42, positive 40. 3, negative 15. Oh my gosh. That's the point y'all stopped me though. If I'd have just kept on running through it, I'd have probably been okay. Point a finger and there's 3 pointing back. Is it? Still. All right, so I'm gonna write it in factored form now. I'm gonna say that x plus 5 times, and I'm gonna write this 3x to the 3rd minus 10x squared plus 8x. Now I'm gonna factor what's left. How do you factor it? Take out an x. I got x times x plus 5. 3x squared minus 10x plus 8. What now? 2 and 12. X plus 5. 3x squared minus 12x plus 2x plus 8. Take out a 3x of those two and a 2 from those two, and it leaves me with x minus, nope. Wait. A cotton picking minute.
Why did you put 3x2? 3x6?
Wait, what?
She said, wait, I caught it.
That's what my grandma used to say. I don't know what it means. Does it mean something bad? Oh.
Break out x, take out 3x. Take out 3x and you get x minus.
My signs are off. What multiplies to 24 but adds to, that's not, those are the wrong factors. Because what? But that's a good. I did that on purpose. See how I self-checked that whenever I got there. What? What multiplies to 24x squared but adds to negative 10? There you go. Negative 6x, negative 4x. So I got x plus 5. Take out a 3x and take out a negative 4. It leaves me with x minus 2. Uh-oh. Negative 4. It changed the last sign. All right, we did all that to find the zeros. I should get how many zeros?
4.
Why should I get 4? The degree was 4. I'm going to stop here.